Okay, so this video is for Algebra 1. This is extended response question involving some exponential functions just to get you used to those extended response type questions, okay? So again, pause it, start it however you want to do it. Should be about 10 minutes long. So it says in 1980, the average annual tuition at two-year colleges was $350. Since then, the cost of tuition has increased by an average of 9% each year. What type of function should you use to model the situation? Well, this whole section has been about exponential functions. If you look in this problem, it says it's increased by this 9%. When you see that, immediately you think of exponential, and in specific exponential growth. So this is an exponential growth function. Okay, so it says, write a function rule that models the annual growth. Let 1980 be year 0 in your function. So again, that's saying years since 1980. That's what x is going to be. And it says identify the variables and tell which is independent and which is dependent. I don't really care about that. What I care about is the function. If it's exponential growth, here is your base function. And again, you'll have this for the test. Y equals a1 plus r to the t. So I need to replace a and r with what they are. So y equals, a is this cost right now of $350. 1 plus r is my rate of 9% written as a decimal. Remember, that's a single digit decimal, so put a 0.0 in front of it, so 0.09 to the t. And then I'll add those two together to get y equals 350 times 1.09 to the t. And there's your function. Okay, so now that we have this function, what do we have to do with it? Well, it says use your function to determine the average annual tuition in 2006. Now, we don't need to use a table and a graph, because what is 2006? This is a year. This is your x value, your t value. So for 2006, right, we need to figure out what value of t we'll use. Well, 1980 is going to be that number that we count from. So the question is, how far is 2006 from 1980? Well, we simply subtract them. So my t value is going to be 2006 minus 1980 is 26. And that's what I plug in. Y equals 350 times 1.09 raised to the 26th. And this will come out to be a number, and that number is 3289. And we're just going to round to the nearest whole number because they don't do decimals in college when it comes to tuition. Just nice numbers. So 3289.7, which is going to make that 9 round up to a 10, which makes that 8 become a 9. And this is $3,290. So that's how much the tuition should have grown from 1980 to 2006. It went from $350 to $3,290. So what I want to do is I want to review how to graph this in the calculator. Actually, no, I'm sorry. We're going to go to the next problem. The next problem requires us to graph it, okay? So that's part 3. So if they give you a t value or an x value, just plug it in. All right. So give me a second. Okay, so now we're going to use our function to predict the average annual tuition at a two-year college for the year you plan to graduate. Well, this is another t value, right? When do you plan on graduating? This is kind of nice because it's important to you. So a lot of you guys are starting high school now in 2015. So the end of this year will be 2016. End of your sophomore year is 2017, 2018. It seems like the year will be 2019 as long as you pass my Algebra 1 class the first time. Haha, that's a joke. So what is the t value? Well, again, the t value is from 1980. Subtract. Can't write 1980, sorry. And I got 39. So that's the t value. So you're going to plug that into your function. Y equals 350 times 1.09 raised to the 39. And when you type that in your calculator, again, you get a number like 10,085.5. And again, I'll round up to no decimals, $10,086. So that's the tuition cost at a 2-year school when you graduate. And again, if you hear the whole political scene, they're all talking about, public education becoming free because student loans are crazy. So it's a lot of money. So when you think about goofing off in the classroom, think about how much money you're wasting by not trying to get good grades. Okay? Scholarships are important. Okay, last problem here. Here's what I was looking for. In what year is the average annual tuition twice as much as in 1980? Use a table and a graph for support. So now we're looking for a tuition amount. Okay? So the original amount was $350. They want to know when the average annual tuition is going to be twice as much as that. Well, we already see that. I mean, it's $10,000 in 2019. So we're looking for when it's twice this amount. So twice this amount is going to be 2 times 350. That's $700. So this is the y value. When is y 700? And to do this, I need a graphing calculator. Now, I've never done this before, but I'm going to try it right now. I'm going to bring up my calculator here into the screen. So hopefully you can see it. Okay? I'm going to get to my clear screen, clear that for you. Here we go. So we need to input our function. And to do this, we input it into the y equals. So I have something in here. I'll clear that. And my function is 350. Parenthesis 1.09, close parenthesis, raised to the, and I know it says t, but I know t is just x. And I'm going to graph this. And don't be surprised if it doesn't show up. And it doesn't, so I must change my window. So how am I going to change my window? Well, my x min is 0. And now, for the x max, let's think of how far away from the year 1980. Well, right now it's 2015, so that's 35 years. So let's do 40 years. You can really pick any number, beyond 10 or 20. But let's do 40. And then the y min, well, let's go from 0. And now we saw that our tuition was 10,000 in that year. So let's go 10,000. And again, these might be high estimates, but it's fine. And we'll graph. And there's my picture. And I'm going to go ahead on here, and I'm going to trace. Oh, I don't need the picture. That's the picture. See the growth. But what I need is the table. Second graph for the table. And what am I looking for? I'm looking for when the y is 700. And I scroll through, and lucky day, look here. There's the closest number. I'm going to write that point down from my graphing calculator. Uh-oh! There it is. Sorry. That point is 8,697. So 8,697.4. That is the closest y value to 700. So what does that mean? Well, the x value is 8. And that's not my final answer. I need the year. Remember that this is the years since 1980, so add that to 1980. And what do I get? I get the year 1988. That is the year that tuition would be double. Okay? So hopefully, and I'll put the graphing calculator on here, hopefully this helped you understand a little bit more about extended response and exponential functions. Thanks for watching, and we'll see you on Monday.